her speech. I think I don't want to stop her motivation. So I think without further ado, I would like to invite Engineer Dr. Nolida Muhammad Dom, Deputy Director of UNESCO, Head of Coordination, Regional Humid Tropics for Southeast Asia and the Pacific, also a Senior Officer at the Department of Irrigation and Drainage. So without further ado, Engineer Dr. Nolida, the floor is yours.
All right, thank you very much, Dr. Kamaru, for inviting me for this special webinar. Distinguished guests, speakers, ladies and gentlemen, in the commemorating of the 29th August 1996 Post-Defense Strategy, I would like to bring you to different topics, whereby today I'll be presenting on the title, The Mathematical and Conceptual Models for the Mudflat. I introduced myself. I was involving with the flood disasters ever since 1993, and in 1993 there was a first major landslide or debris flow somewhere nearby Hong Kong area. So from there, I was involving with the forensic studies headed by the Slope Branch GKR in 1993. This is my presentation layout, where I'll bring you on the concept of the mathematical and conceptual models, historical of the records, and then I go to all different analysis from 3 to 4, and then after that, conclusions of this presentation. So for the rest of the experts, this is maybe your review during this weekend day. Let's go to understand what is a mathematical model that we have usually. So it is a kind of model that use a language that can take many forms of, including but not limited to dynamic systems. If you can see here, there is an example of this weightage factor of the half-life period. And also you can have the mathematical model by having a simple y is equal to mx plus c on the slope. So the example of this mathematical model for a mudflat can be from the stage correlation, that is mud flow that I'm having currently, and linear transfer functions for our previous flood model. So what is the example of the common use of this mathematical model? So you can see from this slide, we can predict the weather forecast, flood, the global warming, the typhoon, as the kinetic and dynamic tropical cyclone. And last but not least, the examples is on the urban islands. All right, let me bring you to this another model, whereby this model we have the concept of conceptual model, whereby we can see all these runoff reservoir, soil storage reservoir, and groundwater storage reservoir. So this is a schematic diagram where it presents all these 3 reservoirs that calculated as a soil water index that will indicate the possibility of the hazard always by using forecasting and post-event analysis such as erosion that we can see at the end of my slides, debris flow, mud floods, or landslides. So the processes can be represented as in above graphics. So this is what it presents on these 3 storages that you can have different calculations is coming from precipitation and then infiltrate to our soil and then finally go to the ground, subsurface flow, and finally goes to the river. Okay, this is what we understand on the conceptual model, whereby this conceptual model usually it will model the actual physical process and that derive the water cycle. So we can see this is the kind of schematic diagram that we can have from a specification from the sky, and then it infiltrate to the storage reservoir, and then it infiltrate and then sink to the soil. Can become on the surface runoff, and maybe some of them will become a shallow runoff, and then finally groundwater. So this is the percentage model where it requires a large data, um, collect and collate. And if you can see through this tank system, you can see how we divide it into different zones and lower zone, and finally go to base flow and subsurface. This is another example of this conceptual model where current on-shelf software, we do have Mike, Swim, Sacramento, InfoWorks, and 10. So those are the conceptual model that we have on shelf. All right, let's go to the historical records. I do have some of the landslides events related to major slope failures. Not all are in here. So we can see the first that triggered the slope branch in JKR back in 11 December 1993, where we have to analyze and help in this forensic task force for the Highland Tower Bukit Antarabangsa. So you can see those are the casualties. And some of the model that we can analyze using the mathematical model, where we can identify whether it is due to slope failure or they are induced by the runoff or the prolonged rainfall. So this is one of the example that we can use in mathematical model that prove that it was not due to prolonged rainfall, but it's due to the slope failure. All right, let me bring you how do we use in the ID to analyze the data on the MATLAB analysis, whereby this event usually when the rain goes into the river. So usually we do have the analysis by having the hourly rainfall data, and then at that event we can refer to the written period of a certain amount or duration. So this is the duration and this is the intensity. And next, we also doing analysis by having the cumulative rainfall, where you can see if, let's say, this is the day and this is the rain, and if, let's say, this is the average rain that you have throughout the years, and you can see if that's the event that you are analyzing, you can see the differences within this period of time. So usually we do collect it and collect the data for the 30 days data in hourly data. And this is how we can see the next example, and this is a histogram that we do usually use as our priority or our main rainfall station in the ID for KL area. And this is another analysis that we showed you on this analysis by having total rain exceeded, whereby if, let's say, the event is in May, and then we will analyze some sort of from the January data for the 30 days data, and we just rank them, and we can see what was the total rain exceeded, and also like this is the monthly average value for the total station. So this is the one that I told you just now through the table that I showed you, whereby this is one of the state for Bukit Antarabangsa on 6 December 2008, whereby the mathematical methods prove and show that it didn't cross this critical line. And this is the warning line and indication line that we do have in the Jeffreys and Macro using the half-life period mathematical theoretical model, that is a physics model, and you can see this is the event that occurred and not occurred. So this required more intensive explanation time for you to understand, because you can't really read the rainfall and the our rainfall. All right, this is an example that I do for the conceptual model on the mud flood analysis in Cameron Highland. I do have two examples here. So the first one will be the event at Brooktown Valley on 22nd October back in 2013, where the event occurred at Brooktown Valley. We used two stations nearby, where you can see Mardi, about 6.7 kilometer, and Gunung Jerai, about 12 kilometers. So we don't have more rainfall stations here. So this is the nearest stations that analyzed and with a partner, and you can see that through this conceptual model, by using the soil water index, we can see that the soil water index really can show you when the event occurred, where the flash flood occurred around 1 p.m. So this is a sample, and another one, the event that we had back in 2016 on 29th May for the collateral. We also used the nearest station. So this is a collateral, and we do have Gunung Jerai. So this is the upper north of Gunung Jerai. Just now it was the southern of these rainfall stations. So the distances are shown here, 9.2 kilometers apart from Mardi and Gunung Jerai of 4.9. And what we can show here, that the saltwater index that we calculated for this flash flood occurred at this collateral, it shows that the saltwater index at the time that occurred at the event, it shows the highest peak, which is 107 millimeter. All right, let me bring you to the current event, not the current event, it's the past event back in 18 August 2021, last 2 weeks or last week. This is how I derived the saltwater index using the conceptual model. It represents the soil water, the soil water in the soil. And you can see this is our axis on the hourly rainfall millimeter per hour, and the x-axis, this is an hourly rain data. So from this axis, it shows 30 days data, whereby the data is an hourly data. And this is the histogram of the rain event at every time within that 30 days period, and you can see this is the highest rainfall millimeter per hour, which was 80 millimeter per hour. And through that saltwater index calculation based on my graph analysis, based on telemetry data that you can have freely access. This is the data that you can plot and put it in your formula on the saltwater index formula, and this is how it reacts from zero rainfall when you have a rain occasion, and as the rain intense and increase through hourly, the saltwater index also will increase its value in millimeters. And you can see here the saltwater index on 31st July 2021, it reached a peak about 50 mm. And as the rain falls and the saltwater index, you can as the rain increase, and you can do the analysis and add to your equation, and you can have a continuous event on the soil water index value. And if you see at the on the 10th of August 2021 at 12, this is the highest peak that you do have in October on the 10th, and the soil water index was about 70. So this is the analysis that you can see. It on 10th of August, it is already reaching 70 and for the soil water index, and that was the same value that usually you can see at the Cameron Highland. And after that, the rain just after that we have the prolonged rain this time, and you can see that on this 16th of August at 6 p.m. the soil water index reached 118. It is too accurate for me to put up this value. Sorry about that. That's generated from this calculation, and it was about 120. You can see this is on the 16th of August. It's already reached at 120. August 120. Depends on the analysis. And there's not much range, but within 48 hours, you can see there's an increment in data, and it goes back to this 120. And as everybody knows, through the reported, through this local reported news that we heard that the mud flood occurred at 3 p.m. and some of them they said 3:30 p.m. So I believe this is the period where the debris or mud flood occurs already at this Gunung Jerai, and but the rain persistently increased, and more rain at this 5 p.m. on the 18th August. You can see about 80 and data of the rain, and the soil water index reached about 240. This is if we calculated through this soil water index parameters based on the assumption values that I have in my calculators. So this is what happened to this Gunung Jerai for my pre-assessment and drop analysis on the Gunung Jerai, that we are looking on the river mud flood. So this is what you can see through this graph on this assessment. And you can see this is another cumulative rain that I plotted for this rain event that we had on this Gunung Jerai area. So this is the exact, not exact I can say, but there's something, the value is something over there. This is the indicator where for the future forecast or warning that we can have for mud flood using the mathematical from the half-life period plus the soil water index that we can add in our existing model. All right. This is the conclusion that I can say on the today's presentation, whereby we can use the mathematical and conceptual model. It's just to help us to understand for the conceptual model, this is the reservoir that we have in the soil, and the mathematical model is just It's just on the sky that we calculated. But the conceptual model helped us to include some of the soil parameters that we're able to represent the reservoirs, maybe 3 to 4 reservoirs that we represent for our model. So this both mathematical model can be is able to predict the relative amount of the soil water content on the slope. So if this soil water index exceeds the value as a electric capacity, so we may say that events will occur. That's subject to our data. Right, the soil water index conceptual model shows the relative capacity of the water retentions on slopes. That shows the value, the occurrence of events such as mudfloods. We only see on the mudfloods, but not the landslides. So basically, this is a natural phenomenon that we are looking at. So based on the result from my rough estimation of the SWI parameters, you can see that the Cameron Highlands events based on Polyterra that I showed you. Brinchang area and Tararata, the soil water index can go within the 49 to 113 millimeters. This is based on the data that we had for 2014 and post 2016, whereby for our previous latest mudflood event, I estimated that the soil water index for that area. It's just an estimation. This is not the final judgment, but this is the rough calculation that I had for my calculation, whereby the soil water index can be ranged from 70 to 120. You can see this now in range about 240, but the burst occurred at 3 p.m. So that was the value that we had. So this is the occurrence event that we received from public reported in the newspaper. All right, for my conclusion, the next conclusion on the future project opportunity. Actually, we need to encourage the higher learning institution to involve with these research studies under the master degree program, especially on the soil water index subject matter, to fill some gaps on the Malaysian mudflood index for whole Malaysians, because I believe we have, if we do focus on this soil water index for the whole Malaysian, it's just that slope master plan, but this is somewhere related to mudflood index, just to focus on the flood under the Department of Irrigation and Drainage jurisdiction on the flood issues. And based on the geological features, we need to study what kind of geological features for different kind of areas that we may see that there's a potential mudflood at certain location. So the proposal on the collaboration and involvement on the mudflood should be from transmittee engagement, especially from NADMA, DPPC, from the Kamaro, GID, especially Praban, who's looking after the floods for the whole country, Malaysia, and for geological subject matters, they must come from GMG, JKR, and local government. Last but not least, I forgot to put it inside, is the MISA should be involved in this satellite imagery for us to understand what are the features that we do have at certain locations. So I didn't put MISA here, sorry about that. MISA, you should be one of the collaborators under city projects. So further information, you can refer to the Department of Education and Drainage Malaysia. From that, thank you for your attention, and Dr. Kamaro. Thank you very much for inviting me.
Thank you very much, Engineer Dr. Nurlida Mohamad Dom, for the, wow, I think it's an awesome presentation, you know, starting from the mathematical model, and she tried to explain, you know, in the easy way, in the layman kind of communication. That's remarkable. effort. I think it's not easy because it's a too complex phenomena per se, but she managed to explain very well. And some of the activities that she done, and also the project carried out by JPS, DID, and give us some clue, what was happening last week in Jerai. And also she presented some of the historical records, how we can learn from there and establish somehow acceptable model to be used. Yeah. So once again, Engineer Dr. Nolida, I believe it's not easy to be the last presenter, and I'm also so more than three hours, during weekend, unbelievable, and we still have, I think, less than 5% participants left our rooms from the beginning of our session. I think I do believe that the presentations sessions provide a lot of input for them, but I think we would like to apologize to the rest of the speakers and also participants that we are running out of time. But what I'm interested to do now, we would like to give one rounds of questions to the given the fact that the mandate of JPS, the ID, and how actually the current this humid tropic center can also support the process of reducing future risks, and also promote this Sendai framework, to support the global agenda in the preventing climatic risk. Please.
Thank you, Dr. Kamarul. On the Sendai framework and our agenda by 2030 and carbon sink by 2065, I was one of the members of the task force of this international intergovernmental hydrological program, phase 9, whereby this phase 9 will be started next year, 2022 to 2029, which is the 8-year medium-term strategies. What they have focusing is on these 5 priority areas where the bridging the data knowledge gap is one of their priority. Other than that, is on the scientific research and innovation, that we have to look on our data and our sediment related disaster, maybe we can focus on. And perhaps there are many chattings that I saw in the chat room, whereby those on the water education in the fourth industrial revolution, that we're supposed to look at it. And the fourth one will be on the inclusive water management under the condition of the global change, whereby we should focusing on the IWRM, whereby this IWRM is water as a resources and water for livelihood, where you need to balance between the two. And SDG 6.5.1 is the most critical data now, where currently on SDG 6 we are in the path for the 2030 agenda. And on the SDG 6.5.1, if you can see what we're supposed to tackle and focus on the 4 ecosystem, and those all 4 ecosystem, they have their own drivers, and those are the 4 ecosystem that we can reverse are the enabling environment, such as the policies, laws, and some of the plans that's supposed to support the IWM implementation. The second one is what I suggested is on the institution and participation, where the range and the roles of political and social economics and administrative institutions and other stakeholders group that help to support the implementation. This is very important. And the one that you said just now, the difficulties on my previous analysis, maybe on the data collecting and data collect. And on the management instruments is the most important part too that we should consider about all those tools and activities that enable decision makers and users to make rational and informed choices between alternative actions. So those are the three parts that I can say. And last but not least, on the financial management, it is very important. If you have the things to do and innovate, but you are not supported by the financial, you won't go anywhere. So, like what you asked me just now, what are my difficulties for this data management and try to understand the data. So those are the important things that we need to understand what the 5 Ws and how one will. So we need to understand on how we can get the data at the optimum level that we can help those people down there. Thank you.
Thank you very much. Thank you very much, Engineer Dr. Nurlida Mohamad Dom. I think it's very timely to pick it up some of the recommended point just now on the data management, IR, WM. There are many initiatives going on, but if we can put in this puzzle into one package, I think we can leverage some of the cross inter-agencies data sharing and make use some of the historical records so that we can improve our understanding for better modeling and prediction, forecasting, and so on. So once again, Engineer Dr. Nurlida, thank you for your time. Definitely, we are running.
Thank you.
I think it's
You're
1
welcome.
hour. I can't really imagine that we still keep it like, well, maybe 20